Today the lecture is going to focus on function notation and composition of functions, and we're going to start kind of back in Algebra 1 again. If y is equal to 2x plus 3 and we want to find y when x is equal to 4, it's as simple as taking and replacing the x with a 4, adding 3 to it, and ending up with 11. Then we move to this thing called function notation, where y was equal to f of x. Just another fancy name. And for our purposes, it could be w of x. It could be anything we want it to be. It could be like a smiley face of x. Who really cares? All right? But it was just another fancy name to say y. So in that case, f of 4 was simply the same as, again, substituting 4 in for x. Whoops. Adding 3 to it, and again getting an 11. It's the same exact concept as we just did with a straight substitution. Now, we're going to take a look at another problem where we're asked to find f of 10 when f of x is equal to x plus 8. Well, f of 10 is simply taking 10, substituting it in for the x value, adding 8 to it, and getting 18. In our next example, we're asked to find f of w plus 4. So it's not a number that we're plugging in, it's an expression. So we're going to substitute w plus 4 into the x value of the f function. So now I get w plus 4 instead of the x, adding 8 to that, and then we're just going to add like terms. So in this case, we get w plus 12. Our next example is an example of what we call a composition of functions. Okay, a composition of functions is where we take and use two functions, in this case some f of x and some g of x function, and combine them together. Now, this notation here, f of g of x, or f of g of 5 in this specific case, I'll write that out, f of g of 5, that's how we say that, asks us to do the following. It asks us to find the g value at 5 first, and then plug that answer into the f function. So what we're going to do first is find g of 5. And we know that's as simple as replacing the x with a 5, which is going to give us negative 20. Once we have that negative 20, we're going to take that answer and substitute it into the f function. So we now have 3, substituting the negative 20 in for x, add 1 to it, ending up with negative 59. Our next example doesn't ask us to do a composition, but asks us to simply add the f and g functions together. What is the f function? The f function is just 3x plus 1. And we're asked to add that to the g function, which is negative 4x. Combining like terms, I get negative x plus 1. Now we're asked again to do another composition. We're asked to find f of g of x. But in this case, we aren't asked to plug a value into the g function first. We're just asked to substitute the entire g function into the x value of the f function. So let's do that. I have 2, and I'm substituting the g function into the x value. and then I subtract 5. So f of g of x in this case is 16x plus 4 minus 5, or 16x minus 1. Now, I could also, if I wanted to, find g of f of x. Is that going to be the same? Maybe sometimes, but not all the time. So in this case, I'm asked to take and substitute the entire f function into the x value of the g function. So let's start with the g function. It says 8 times x, but I'm not using x anymore. I'm substituting the f of x value into that. So that's 2x minus 5. And then we're going to add 2 to that. Let's do a little distribution. 16x minus 40 plus 2 gives me 16x minus 38. And notice f of g of x doesn't necessarily equal g of f of x. So the next topic is going to be inverse functions. Now, and we're going to tie that into compositions. We said that f of g of x and g of f of x aren't always the same, but sometimes they are. In fact, if f of g of x happens to equal g of f of x, and both those also equal x, then we say the two functions f and g are inverses. The notation for inverse is this f to the negative 1 power, although it's not a negative 1 power, that means the inverse. We're asked to show that the function 2x minus 5 and the function x plus 5 over 2 are inverses, and we're going to do that using compositions. So, our first step will be to find f of g of x. Let's do that. F of g of x is going to be the same as plugging the entire g function into the f function for the x value. So that's 2 times x plus 5 over 2, and we're going to subtract 5 from that. Now, the 2's reduce out. I'm left with x plus 5 minus 5, which ends up being equivalent to x. That's exactly what I wanted. Let's look at our initial premise, that if f of g of x and g of f of x both equal x, and we can say the two functions are inverses. So the next thing I have to do now is find g of f of x. This asks us to take the entire f function and plug it into the x value in the g function. So the entire f function is going to be 2x minus 5. I'm going to add 5 to that and put it all over 2. Well, we know 5 minus 5 is 0, so I have 2x over 2, and the 2's reduce, and that's equal to x. So we know that f of g of x is equal to x, and g of f of x is equal to x. Therefore, they are inverses. Done. All right, so let's move to our next example. We want to now take and find an inverse of a function. What we've done is prove two functions are inverses, so now we're going to find the inverse of a function. In order to do that, we go through this process. All right, we take and switch the x and y value and then we're going to want to solve for y. So f of x is equal to x cubed plus 7. That's the same as y equals x cubed plus 7. In order to find the inverse of this function, I'm going to switch the x and the y. So that means x equals y to the third power added to 7. I want to isolate the y. I'm going to subtract 7. That's going to equal y cubed. And to get y by itself, I have to take the cube root of both sides. So the cube root of x minus 7 is equal to y. And that we call the inverse function. So it's as simple, once again, as switching the x and y and solving for y. Quick lesson today. So what I'm going to ask you to do is solve these 3 questions, put them on the form, and we'll discuss it tomorrow.